Hello, everybody. Good morning. I see we've got two waiting in chat already. I can see one of you, Bruno. Welcome. Good for you to join the stream actually today, this morning. I don't think we've had the pleasure of having much like direct one-to-one communication other than through GitHub so far. For the context of those of you who don't know, Bruno is one of the other PyO3 maintainers, and so it's very exciting to have you joining me this morning here. Thanks for joining. So today I've been a little bit slow actually on getting sorted for the plans for the stream this week. I guess we should probably start by talking a little bit about what we're doing on the stream today. And also I think I need to just quickly update the stream title because it still doesn't have any particular details on it. How do we do this? I haven't tried to do this live before, so you might have to bear with me. Here we are. Okay. So I ran a little quick poll on Twitter and Mastodon to figure out. I had two ideas that we thought we might look at. One was going into PyO3's procedural macros and deprecate it, or figuring out how to do some deprecations for the API that we're planning to mark as deprecated in PyO3 0.21. But what seemed more popular this morning was to go do a PR for CPython. First, we'll talk about that a little bit more in some context, but let's just first update the stream title. Let's call it Building a PR to CPython, I think. And what we're doing, we're looking at the Unicode data API today and writing a CPython patch to make it easier for PyO3 to use this API downstream. Cool. I can always update that a little bit more later. I think that'll probably have gone through now. So let's take a look at what we're doing then. If I can just, cool, I've got everything in position. Good morning, David. Good morning, Blatz. Blatz, I think you've been contributing to PyO3 a little bit in the last week. I recognize your name. You've been joining in with the new bound API that we're doing for PyO3 0.21 as well. So thank you for joining, and thank you for starting to help us get going on building that API out. It's getting close, and I've been appreciative of your help too. And then, hey, David, I think I recognize your name from a previous week, so good to see you again. Yeah, please enjoy. This week we're doing less Rust and more C, I think, but we'll be talking about both. So let's dive in and start talking about that. So if any of you saw the stream from 2 weeks ago, we went through PyO3 FFI, which is these APIs. I'm actually looking at it already on VS Code as well, which is quite nice. So we went through these definitions that PyO3 has in Rust for linking against the CPython C API. Basically, it's the stuff that's defined over in C in the Python interpreter that we're allowed to use downstream for either embedding Rust in Python, or Python in Rust. Yeah, both ways around. And we went through, and the recommendation, especially of Peter Victorian and Victor Stinner from the core developers who joined us on that stream, was that we should look for these symbols that are starting with the preceding underscore and really consider not using them if we can avoid it in PyO3, because they don't really want to have any stability policy on. And my previous impression had been that the stability policy was that it would probably be fine over a Python minor release series, so like it wouldn't change in 3.10, but it might change between 3.10 to 3.11 or so forth. But the impression I got from the conversation 2 weeks ago was that really they don't want to have any stability guarantees on these underscored APIs, so it could change from 3.10.2 to 3.10.3 or whatever. I think in practice that would be impractical because it might break a lot of things. I'm sure that PyO3 isn't the only thing using these underscored APIs, but it's a nice target for them to aim for. And so if we can help like do our bit downstream in PyO3 to not use these symbols, I think that goes a long way towards like building some goodwill so that when we do need things that maybe need other use cases that we haven't yet got, then we've got some kudos built up, and we can maybe consider asking for them to put a bit of effort in to help us out that way around too. And so the one I'm going to zero in on this week, well, we built a list from the stream 2 weeks ago. One of them I actually already have a very small PR open on CPython for. It was just some type definitions that wasn't too much work. And then we talked about all of these. I don't really want to go through all of them in loads of detail, but we talked about how there was this particular symbol, PyUnicode compact data, that we picked up when we were searching. And if we jump to that in VS Code now, what we find about it is, well, it's got this definition here in PyO3 FFI as a pub unsafe function. So it's probably a C macro. And we'll jump over to the C source code in CPython in a moment. I'm just trying to give a bit of context first before we do that. And really, if we search for where this is used, well, we found it because it was used in this test over in PyO3's tests directory, or test file for the FFI tests directly. And so we could just like not use this symbol here and pretend that it was all fine. But really what's going on under the hood is that this API, we're back in the PyO3 FFI source code now, PyUnicode data, is using this macro and underscored stuff under the hood. Again, because, and we do use this one, PyUnicode data, in PyO3 more directly. So it's reaching into private implementation details, which maybe on its own is kind of fine, but there's a particular quirk about PyUnicode data and this symbol, which makes it like a particularly gnarly one that we probably want to talk to. Oh, good morning, Peter. Thank you for joining as well. So I think for a bit of context for everyone else on the stream, I actually mentioned to Peter that I might be doing this week. And the recommendation from Peter was that we might, whatever we propose on this stream may not end up being actually accepted into CPython, so we have to be realistic about that. But at the same time, I think it's interesting for all of us to really go through the process of writing what should hopefully not be too large a PR for CPython that might help us out with a use case downstream here. And really, we can all chip in with the design if we've got ideas on how we think it should look. So what's the significant thing about PyUnicode data? So PyUnicode data is, we can bring up actually the CPython docs is probably good. Unicode objects are what used to be called, well, it's what you know in Python as stir. Because in Python 2, we had the separation between stir, which was purely for ASCII text, and Unicode, which was for full Unicode data. And in Python 3, that distinction was removed. Stir became more like what we have as bytes today, and Unicode became what we now know as stir. And so that's why in the C API, it's still called PyUnicode. It's a bit harder to rename it at that level. People don't really want to, so we just live with it. It's not too bad a distinction. But so PyUnicode data is meant to be, if you've got, can we see that on stream? We can see that. I think the font size is big enough on both sides, by the way. If the font size is too small, please just give me a heads up in chat and I can make it bigger. I've also tried to like up the contrast a little bit on the VS Code text this week, because I noticed that it seemed a little bit grayed out because of the background. So hopefully it's easier to read this week. If it needs any further tweaks, please just mention in chat. And so PyUnicode data is a return a void pointer to the raw Unicode buffer. And Unicode has to be a Unicode object in the canonical representation. I think that the canonical representation is a bit of a detail that we don't really want to look into here, but the thing to be aware of is that there are 3 kinds of encoding that CPython currently allows the Unicode data to be in, and it's one of these 3 values: 1 byte kind, 2 byte kind, and 4 byte kind. And that's because in Unicode's specification, I think, somebody correct me, I'm not a complete Unicode expert, but my understanding is that Unicode copoints can be anything up to 32 bits as the maximum copoint value at the moment, and probably for, I don't know if that needs to be extended ever. And so that would be 4 bytes, right? 32 bits, 4 times 8 to 32. And so the idea is that CPython chooses an encoding that's most efficient depending on the code points that you've got in your Unicode text. And so PyUnicode data is handing out a raw pointer to that encoded data, but you also have to use PyUnicode kind to work out which encoding it's going to be in so that you can reasonably interact with this stuff. And generally, you don't need to use this API because there's an alternative one, which is much better for what we want to do in PyO3, which is this one, PyUnicode as UTF-8. We actually want a different file. This one, PyUnicode as UTF-8 in size, which the definition here you can see is much shorter. Oh, sorry. Where have we gone to? Caught the scroll bar there. Here we are. This definition is much shorter. It doesn't have any body because it's just a symbol that's exposed by the Python interpreter that we can call into. So this doesn't expose any implementation details. And not only that, it's giving you a UTF-8 encoding with a size and a pointer to the data, which is more or less exactly what... it returns a pointer to the data, and it sets the size into some location that you ask for the size to be set to. And so this is great for Rust strings. If you're familiar with Rust strings, you'll know that they are UTF-8 encoded, and they contain their length internally as well, so that they know both the data and length. So this is a very, very good match to a Rust string. But sometimes there have been a couple of use cases where PyO3 users have wanted to go to use this PyUnicode data instead to get access to the raw buffer. And if we just click through the definition of how this looks, so this is a macro. We'll go look at it in the C source code in a second to see what we've tried to mirror. We can click through into one of these. This is PyUnicode compact data, so there's different forms of the Unicode object. We get some other checks. Eventually, so maybe if it's ASCII data, then there's one particular path we'll go through. And then eventually, we're going to have to read the state from somewhere. And so one of the forms that a Python string can be represented at is this PyASCII object, which it's a Python object. This is like a standard layout of how a Python object would look at the C level. We've got the Rust definition of it here, but we'll go look at the C again in a second. It is a Python object, so this always has an ob base field. It's got a length because it knows how long the string is. The strings cache their hash. PyPy doesn't actually expose this field, so we don't show that from PyPy's side. And then it's got this state, which contains a lot of the information about how the PyUnicode string's actually working. And it's what we call a bit field. So as far as we can do it from Rust, Rust doesn't have these C bit fields. So all we can say is that it's 32 bits, which contain some data that describe the state of the Unicode object. In C, the definition looks a bit more like this, where there's 2 bits that are used for the state and whether it's intern, 3 bits which are used for the kind, which is these different PyUnicode kind values. Then there's different bits of state saying whether it's a compact object or an ASCII object. To give a flavor of what that means, we've got a PyASCII object here, but a different form of the PyUnicode object is this compact Unicode object, which has an ASCII object, and as it's like, it is a PyASCII object with some extra fields. And so we don't have state here because the state's still part of the PyASCII object in a structure. So these different bits are saying which of the layouts CPython should be reading in. And then this ready bit is actually not part of Python 3.12 anymore. So I think there's several problems going on here, right? One is that we've got these different fields which we can't actually very easily read to from Rust at all. And so there is this code here, which we've written with the help of an automated binding tool called BindGen. I don't really want to talk about this code too much, but it's how we've worked around the fact that we don't have the ability to read this bit field directly as like a Rust language feature. And really, we probably don't want to be doing this at all. So the motivation of looking into the CPython patch that we'll do today is to remove the need for us to do any reading from this state over on the PyO3 side. It would be nice if, as far as PyO3 is concerned, we can just have symbols, a bit like we've got here for PyUnicode as UTF-8 in size, that allow us to do the things that we currently need to read the state directly for. And so we might have to go take a list of those in a second, but I think first we can flip over to the CPython side and see what that looks like, as so we can understand a bit what we're trying to modify. So where should we jump first? Let's see. We could try, and I think I actually have I have a checkout of CPython, so let's jump over to that. And we're probably going to need to check out CPython main, and we'll see what we're going for. Let's just tidy up this a moment. We're on main, but probably it's worth pulling again. To make things easier as well, this week I'm trying to use the VS Code embedded terminal. So it's in a different position. I think the terminal font size should be about the same for everybody. But if it's not very legible, then please let me know. What I'll try and be doing is when we're not needing the terminal, I'll hide it, and then I'll show it again when we need it. So we've done a git pull, and let's go look at, so on the PyO3 side, we had the CPython's Unicode object dot bindings open. And so on the CPython side, we've got the same thing. So this is, let's go open the file explorer. So we talked 2 weeks ago about how there's what's kind of the more stable, guaranteed to be kept around for a longer time API in this top level include directory. And then inside the CPython directory, my understanding initially was that was all really private implementation details that shouldn't be touched. But I think what I gathered from the stream 2 weeks ago is that there are symbols in there which are acceptable to use, but the distinction is not super clearly defined at the moment. Whether they're prefixed with an underscore or not is a good heuristic. But they can kind of be regarded to some extent as version-specific API that we can depend upon. So I think for the sake of this stream, we're probably going to focus on this version-specific API and try and make a more stable version of it for PyO3 that doesn't need to expose reading that state directly. So we can go look at this CPython Unicode object.h file. And I think what I'll do is I'll add PyO3 to the workspace as well, so that we can compare what we have here on the CPython main versus what we've written over in PyO3 to give us a bit of a sense of what's going on. So here in the PyO3 source code, we've got in the PyO3 FFI subdirectory, we've got the CPython subdirectory of the source, and then it's this Unicode object.rs. And the idea is that we want to match as much as possible the Unicode object.h file inside the CPython subdirectory of CPython's include. So this is the definition here. And we sometimes go a bit out of sync because this is maintained by hand. If you're interested in helping us either guarantee that the files match more closely by either helping us just keep up to date or by doing some more automated step, it's definitely an interesting thing for us to think about. And then in addition, let's scroll down to what we were looking at before. So the PyASCII object over here. Is there. And then let's see if we've got space to pull them side by side. Oh, I've done that wrong. Please excuse me while I fumble with keyboard shortcuts. Right, there we go. Yeah, part of my reason for not wanting to use the VS Code integrated terminal is that I am really not great at investing in learning shortcuts. So it's a little bit cramped, I think. But despite that, let's just have a side-by-side view just while we're getting a sense of what's going on, and then we'll probably hide the Rust source code again for now. So here is, I think this is going to be the same thing over on the CPython side. So we've got type def struct. I've just collapsed it for a second. At the end, it's naming the struct as PyASCII object. I think that's because there's distinctions in C. I don't know the full. This is where my C knowledge is kind of limited. You can also name a structure on this side, up at the top position, but there's different ramifications when you do this. I think it's generally because you then have to start calling it struct PyASCII object all over the place in code. So you want to type def it at the end. I don't know really the historical reason for that, but that's how I tend to see C source code written. And so here there's a long comment, which we haven't replicated for obvious reasons, which is talking about the different layouts that these Unicode objects can be in. And then after that, we've actually got the fields. So PyObject head matches what we call PyOb_base over on the PyO3 side. This is just a C macro, so it gets text replaced in. We can see that the definition of PyObject head is just PyObject ob_base. Oh, crikey, click that again. So it's very, very similar to what we've got over on the PyO3 side. Then we've got the length and the hash, as we discussed. And then we've got here, we've got this structure, which is how we're building this bit field up with these values interned, kind, compact, ASCII. There's a new field statically allocated. It's no longer ready. So you can see that what I'm talking about already, I think this was probably more closely the Python 3.11 definition. And here we're on Python 3.13 alpha. So it's changed. And it's not a good thing that that's falling out of sync. So really, we don't want to have to think about that on the PyO3 side. Okay, so that's the structure. And then let's also jump over and look at the functions that we were talking about. So maybe a good one to start with is PyUnicode kind. And so how's that working? Well, on the PyO3 side, we have, first we are in debug mode, we've got some assertions, and then we're casting it to that PyASCII object structure we've just been looking at. And we're using a helper function to read that value out of the bit field. How does that look on the CPython side? Doesn't look like symbols are working so well there. Let's just jump. It should be in this file. Right, so these are the different values of the constants. And then we have the definition. As I mentioned, I thought it was likely to be a macro, so it's text replacement. If you write PyUnicode kind bracketed with some operation, then you'll get text replacement for this, which looks like another macro. This looks like it's protecting you from assigning to PyUnicode kind by forcing it to be an L value. Prevent using it as an L value, forcing it to be an R value, sorry. So that's just because it's a macro, it gets text replaced into whatever source you use it. That's not going to be the same problem over here on the PyO3 side, so we don't really worry about that in the same way. It's then doing a cast, as we talked about, and you can see it's directly reading into the bit field. And this is a macro, as we said. So that's why we end up having to reflect it on the PyO3 side as an inline function. And I think what we're looking for is to instead make this into a function so that PyO3 can read it as a function. But then if you're just using C code still, you could continue to use it as a macro. So we can have a look at what that might look like. I think let's first gather a list of what these functions that we might want to replace are. So I think we can probably get them all by searching for uses of / or this or looking into the state in this file might be a good hint, because then we can start thinking about what we're going to be doing. So PyUnicode kind. We have PyUnicode check interned. We may not do all of these today, because I think really the ones that are relevant for the PyUnicode data, we'll work out which ones are also relevant for the PyUnicode data API that we were looking at. So check interned is ASCII. Again, these are all reading the fields. Is compact. Oh, Peter, sorry, I've just seen your chat message. So include is long-term stable. Include CPython is the full public API with 2-year deprecation period, and include internals. Yeah, cool. That's a guideline. It's not totally strict. Yeah, that's about my understanding too. Cool. PyUnicode is compact ASCII, which is both reading both of those fields, and PyUnicode. So that's an underscored symbol. PyUnicode data is using under the hood PyUnicode compact data or PyUnicode non-compact data. So this is where we started talking about from the beginning. And that is in turn just using PyUnicode as ASCII. And okay, right. And then PyUnicode non-compact data is checking instead that it, asserting that it's not compact and then casting it to a different structure. But either way, we're always coming out with the same void pointer. So it's these 5 things which are reading the bit field at the moment, which makes sense because those reflect the 5 things currently in the bit field, right? Interned, kind, compact, ASCII. Oh, statically allocated. Doesn't look like that's currently referenced anywhere else in this file, so let's not worry about that one. So I guess in terms of what we're going to aim for, we could try and just replace these 5 functions with public symbols so that we can at least just have those without needing to read the state. That's one option, which could be quite a straightforward way to go. We were mostly looking at PyUnicode data. So I guess option 1 is wrap these. Option 2 is we really want PyUnicode data. So we could just make PyUnicode data a macro or a symbol. And I think that would remove the need for is compact or all of these checks on whether it's ASCII or not, right? And then so the other one that we do need though is we need PyUnicode kind so that we know how to interpret that pointer that we're receiving from PyUnicode data. And PyUnicode check interned, I haven't got any intuition for whether we need this at all. It's an interned string, in my understanding, is one that's basically been fixed into static storage so that it's going to last around the full lifetime of the program. PyUnicode data is already a function. Sorry, Bruno, you mean... I don't think it's defined as a function, though, at the C API, right? That's the problem that we're encountering here. There isn't a... Oh, sorry, PyUnicode data here is a function. Right, it's a function, but it's not... it's not exposed as an importable symbol. It's a static symbol. So one option is just to change it so that PyUnicode data does export a symbol, which we could bind to. This is in the .h. So I think so the gotcha here is that this is a static inline at the moment. So that means that it's not a symbol we should link to. Yeah, I agree, Peter. I don't think we need the intern status. We do occasionally intern strings. We expose that from the PyO3 side. But I think actually wanting to check whether a string is intern seems like a fairly niche case. So I wouldn't think that there's any value in that. So I think we can just focus on getting these two APIs, PyUnicode data and PyUnicode kind, to have single symbols that we can link to. And so I guess what do I mean by that? PyUnicode data, it's a function, as Bruno's pointed out, but it's static inline, which if my C understanding is correct, means that this, because it's in a header file, it basically, it can get compiled directly into the .c files which are using this symbol, and it doesn't get exposed from the binary. And so maybe we should just have a quick look. So I think we'll target option 2. We'll go for PyUnicode data and PyUnicode kind. Right, so back to the terminal. If I can get my shortcuts right. Oh gosh. Sorry about this, everybody. Like I say, I'm learning this shortcut for the sort of first time, really. So here we've got the CPython source directory, and we should probably take a quick look at how we compile this thing, actually, because that's going to be relevant. So I've come across before the CPython dev guide, which I think is the thing that I've certainly found most useful. Let's make that font a bit bigger. Ping me on stream chat if that's not big enough still. But this devguide.python.org is a reference material for, as it says, new and experienced contributors. It's kind of like the walkthrough of, if you want to be writing a patch to CPython, then this is the material that you can use to figure out all the fine details of what you're going to do. And I've looked at this a few times before when I've tried to do various bits and pieces for CPython, but I think it's quite helpful if we have a look through and just refresh on stream our memories of what's going on here. So first it's talking about the fact that we'll need to clone the repository, and then next we'll want to build the repository. So step 2 is set up Git, step 2 is clone it, and step 3, which I think we can jump straight to because we've got a clone already, is to build it. And so it's using this configure script and then make. And I guess we could take a very quick look at it. I don't really know too much about the build system here at all. I think that this looks like a shell script, which does, when I've seen it, we'll run it in a sec. It checks for a lot of things so that your build of CPython works for your machine. I don't really know too much about the machinery there, so maybe let's not go further into that. But what we can do is we can run this command, and it's all wonderfully set up to just do what we expect. Maybe just in case I've got something there before, let's do make clean. Oh, that was not quite what I was expecting. It looks like it's run off configure already. I wonder if we should just kill this. And I think rather than try to clean it, I'll just run this. But what we're expecting after running that command is that we should end up with a locally built copy of CPython, which would include any changes that we've made. While that's compiling, question from Bruno. Is there a reason why function like C macros, macros and just not functions? It's for performance reasons. So making a function, you're then asking the optimizer to figure out whether it needs to do inlining of the function or not. Whereas by making it a macro, you're going to guarantee that it's always going to get inlined directly in there. Oh, we've had a build error. That's a bit worrying. Hmm. I suspect that that is because we have some old build artifacts around. Maybe make clean. So it is make clean. I did try to run that. Okay, it ran off configure earlier, but it looks like that's now happy. So hopefully this will now build. Thank you, Peter, for bailing me out there. Oh, I've just run configure again. Sorry, not the most efficient use of time, everybody. One moment. So yeah, trying to elaborate on your question in a little bit more detail, Bruno. So I get the most basic thing you could have is you could have a function. Well, if it's static inline void, you can put it into a header and it will work out very similarly to a macro. But I think with the macro, you get additional kind of features of the fact that yeah, make clean cleans up the problems. Yeah, exactly, Peter. Thank you. That looks like it's worked now. And so with the macro, you can do things like you could use the same argument to. I'm not sure what a good example is actually. I've seen funky stuff done with macros. Nothing's coming straight to my head. This is where my C knowledge is probably limited. But I think that generally the complexity is that by making a function, you're forcing. It might be typing as well, actually. With a macro, because it's just text replacement, you can play a bit faster and looser with the types that are going in and out of the macro. Oh, I'm not reading. Converting this macro to a static inline function would introduce new compiler warnings on compare signed inside numbers where kind is type is an int or an unsigned. Right, yeah. So it's actually, I think, where I was just getting to. The point of the macro is that you can get away with the types not having to match exactly the types that you would have to define a function as having. And so the macro gives you that additional flexibility, right? And then the next step away from a macro, if you like, would be to make a static inline function in a header file, which again, it gets inlined into every compilation unit of your C program. So this doesn't become a symbol that we can actually look at. All of these, Unicode compact data, non-compact data. And so it's kind of the best option for performance, because then it means that the optimizer can do whatever it likes with this function down in the C source code in each compilation unit. So having finished our compilation over on the right, let's just tidy up. So we should find it's okay, fine. It's not marking it as something which exists, but I think what we will see is, yeah, we've got this one, libpython 3.13d.a. So that's what we just compiled. If we get some timestamps, lib13 python 3, we got the timestamp 1039 just now. And that's actually a static library because it's got a .a. So that's not quite what we were looking for. So we're going to have to configure one more time. I think it's enable shared. We can check this over in the dev guide. How do we search this? Oh, yeah. Sorry, I'm just scanning through very quickly because we want to build a CPython shared library. Yeah, it is enable shared. Okay, great. And there's some details and warnings about why you might want to be careful, but that's fine. So we'll have to configure again with this enable shared flag, and then we can build the shared library. And what I want to do is we can look at the symbols that are exposed by the shared library. And what I'm expecting to find is that this symbol PyUnicode data doesn't exist in this shared library because it's a static inline function. So we'll have to wait another moment while it builds. But so the next step down from a static inline function, which I think is what we will be wanting to get towards for the actual definition that we're looking for here, for the solution we're looking for here, is we want to actually have a symbol that's defined not as static inline, but we want that to be in a C file so that that then gets compiled and exposed properly. So we'll have to do a little bit of working out in a sec. But first, so we need to build this. I don't know, for those of you who do much Rust or C development, Rust is famous for having slow compile times, and sure, it's reasonably slow at some things, but at least it's good at caching dependencies. In principle, C, because each compilation unit gets compiled in isolation, you can get that same kind of caching where you only recompile what you need to. If you change a header file, you have to rebuild the whole project. So we'll have to have compiles that take about that duration a few times over. But that shouldn't be too bad. So now if we take a look at what we've built again, this time, as well as libpython 3.13d.a, the one that we built oh no, that one's still old. So we don't have that one anymore because we forgot the with PyDebug flag this time. Doesn't matter too hard. So we just built this one, which is a static library. And then we've also got the .so form, which is the shared object. So this is the libpython, which contains the symbols that get exposed that PyO3 could in principle link against if you were embedding Python into Rust. But it's the same set of symbols which we would also be able to use when you're going the other way around and running a Rust inside Python. So we can use, I think it's nm to look at the symbols that are exposed in the shared library. You'll have to forgive me if I get this wrong because I'm a little bit... oh, that's not right, is it? This is what I meant to do. I was going to pipe it into less. So yeah, here we can see the symbols that have been exposed by the shared library. And I can't remember exactly the difference between T and D. There is something, we could look at the NM man pages to refresh our memories on this, but I think it's probably more detail than we need to jump into right now. But what I wanted to look at was just the PyUnicode symbols that we can find. So we see all these, and it looks like these are alphabetical. I'm not sure whether they all will be, actually. It might be worth just going out and piping it through sort first. Oh, no, that's not been very... Is that going to be any good? Unicode data is not found anyway. Sort wasn't the best of ideas because it sorted it by the first column, which is the memory address, isn't it? Maybe it was already sorted in alphabetical. I can't remember. But either way, the point that I'm trying to make is that there are lots of PyUnicode APIs which are exposed for us to use. And if we search for PyUnicode data, it doesn't show because it's defined as this static inline function. So now's a good time to start figuring out what we're going to make our patch to CPython look like. So we, just clicked on something I didn't mean to, but I think it's fine, hasn't interrupted the stream. So we want to try and move this into a C file. So the right place to put this would be, let's just hide the terminal to create a bit more space. Unicode object. I've got a typo there, haven't I? .c. So this C file contains the implementation of all the functionality related to Python Unicode objects. There's a lot going on in here, but if we, for example, search for PyUnicode new, then this is the function which is used internally by CPython, but also externally by PyO3 to create a new string object. Actually, this one we don't tend to use. We tend to use PyUnicode from UTF, is it from string size? I think it's this one. I think this one, let's jump over, check in a browser. Yeah, the bytes will be interpreted as being UTF-8 encoded. So this is a good fit for passing Rust strings to Python. We can basically pass a pointer to some Rust strings data and the length of that Rust string. And then it goes off and does other stuff in the implementation, which I don't think we need to read through, but the point is that this symbol is exposed for us. And I guess we want to go and add, really, where's UTF-8 and size, which we talked about earlier. So here's the functions which we have to convert to UTF-8, and maybe just beneath these, we could talk about adding our PyUnicode data. So, I mean, crudely, we could just do this. This isn't going to quite work, but we could at least see what the result is. I think the problem here is that because this is defined as a macro, you can see that it's created a big mess. So I think one option is that I think that the Python API naming conventions typically have uppercasing for macros and lowercasing for functions. So Peter, you might be able to weigh in on this. If it's an appropriate choice to choose to name it with just a lowercase data like this, or whether we should be trying to just repeat the same symbol with uppercasing. I think for the moment, let's start like this and compile it and see what happens. So I think that just putting this symbol into the C file might go a long way towards getting the export we want. We might have to do a little bit more. Let's compile and see what happens. So because we've just changed one C file, this is the point I was making, we only need to have that C file recompile, and then there's a little bit of linking that needs to go on to join all of the compiled C files together, or .o files they become, into the final shared library. So if we check what we've got now, we can see that 1051 is indeed the time, so that makes sense. This file has just been recompiled. And let's go have a look in this now for PyUnicode data and see. No, so it's not come through yet, which is, I think, what I was expecting, because I believe that we have to declare this as being externally visible. And I believe that the normal way to do that is to expose it in a header file declaring it that we want that to be the case. So first, I've just realized that because we've given it a different name, we might as well just do this, right? So we can call the static inline function from the function that we're going to declare as an export instead. And so now we could jump back out and let's put beneath it. So do we have any exports? We haven't got them here, but if we go back to the, yeah, this is the stable API, the CPython include Unicode object.h, which contains PyUnicode as UTF-8 and size. And so this is what I was meaning by it looks like it needs to be exposed. So we can have, we want to have one of these definitions in a header file just saying that this symbol exists. And regardless of whether we wanted to expose it in the shared library or not, having a declaration in a header file is very important for C compilation in general, because it's the individual .c files can't see the contents of other .c files. They refer to each other by using these includes of header files, so they only know the definitions that are written into header files. I'd be surprised if any other C code is going to use this, because it can just use directly the more available PyUnicode data. But we can declare this here. So let's just add a little comment. Possibly that's good enough for now. And so we need to check the type definitions, right? Because that's obviously, we've just copy pasted it. We can use the ones that we've got here. So it doesn't return a char pointer, it returns a void pointer. And it only takes one argument, which is an unchecked, but it doesn't check the type of it. It's just a Python object. And so that probably hints to what we need to think about. We might need to think about checking the type of this thing as well, because generally with these capitalized inline functions, we tend to be a bit more relaxed about whether they are the right type or not. So probably we probably want to do, this is going to get more complicated now. So maybe we'll just add an assertion for a moment. That's probably not a good way to do it. But this will at least check. Thinking in Rust, trying to do a capitalized assert or an assert with a bang at the end. This is at least going to be a safety valve while we're working out how this API works, because then we're not going to read invalid memory if it's not a Unicode object. I think this is like a good idea to put in. The problem here is that we don't want actually this structure to be in a real program, right? Because an assert will just blow up and crash. And so that's not very helpful. I think we can probably just return null instead if it's wrong, but we'll leave it like this just for the moment while we're working out what's going on. So having added our public declaration and our implementation in the C file, we can build one more time. And you can see that this time every single .c file is having to recompile, because every .c file is including that string header to some, whether directly, probably through including python.h, but they've all now got to recompile to take into account that that header file changed. Great, so that having recompiled again, let's just sense check. We can see that that has now recompiled times 1057. So let's go and have a look in our newly compiled Python shared library. And this time, I'm very much hoping to see that this PyUnicode data symbol exists. And it does. So that's a relief, because if it hadn't showed up, then there was something that was beyond the limits of my C knowledge, which might get us a little stuck, but it has. So we're good. We can actually now if we set up a Python environment, we could get PyO3 to use this symbol already against our locally built CPython, which might be an interesting way to go. Why don't we do that? And then we can come back to error handling afterwards. And then maybe we can also think about whether naming or things like that need to change as well. So let's have PyUnicode kind as well. And PyUnicode kind will return one of these. Well, this is going to get more messy, isn't it? Because PyUnicode kind is already the name of the type, so we can't just lowercase this one. So I'm going to call it getKind for the moment. This is a good reason why it's all getting a bit fiddly, and we might want to think about these names a bit better later on. But let's at least get these two functions in, and then we can try and build a PyO3 that works against them, which would be at least a pleasing result to see that we're heading in the right lines. So let's call it getKind. And much in the same way, I think we can just do something like this. We just need to change this to return like that. PyUnicode kind is undefined. Have I got capitalization wrong? Is that? Oh, thanks for joining, Peter. Have a good rest of your day. That's surprising to me. How's it defined over on the CPython documentation? It's just defined as an integer. So, okay, fine. I think in that case, we can just call this an integer again. Maybe in C, there's some rules about the enum naming. I have to admit, maybe it's just not included. No, it should be. I don't have a good intuition for why that didn't work, but either way, we'll just use int for now. So if we recompile one more time, then this time we should have those two symbols ready to use. And then we can switch over to build a PyO3, which is working against this custom-built Python interpreter. Thinking a little bit further ahead, it might have been smart for us to work on Python's 3.12 branch rather than against Python 3.13's main, because I don't know what other changes have gone into the main branch which could impact the ability for PyO3 to work at all against it, because we haven't made any effort in trying to get PyO3 to work against Python 3.13 yet. So we'll just have to see. Yeah, the compile's done as we expect. Let's just check the symbols there. So we should now have PyUnicode getKind as well. Cool. So I guess I should talk about at some point why Peter had a worry that these might not get accepted. I think that the main worry was that, well, I mean, the naming's a bit funny. Can turn off O3 optimizations. Yeah, that's a good idea. I don't know what the flag to configure is, Scott or Suf. If you know what the flag is that I should be passing to configure as well, I'd be very happy to. Maybe I just need to enable with PyDebug again. Perhaps if someone wants to look up as an exercise in the CPython dev guide what the correct flags to pass to configure should be, I'm happy to rerun it and we can try and have some faster build times. Great. Thanks very much, Suf. So yeah, I think that Peter's concern was that it's not really guaranteed that the CPython developers will want to always have PyUnicode objects work in this way, where it's trying to choose one of these three encodings according to what's most memory efficient. So maybe the one concern there is that by adding these APIs, it's kind of helping drive further the sort of exposure of the fact that that's how these Unicode objects are built. So that might be something that like gets us blocked in review. And I guess the other thing that might block us is naming concerns, because we've added these new names and I'm not sure whether they will exactly match what CPython's developers would want. So we'll have to see. Anyway, it's worth trying to get this patch across the line. And then hopefully if there's some feedback, we can always go and tidy it up another time. I'm not quite sure where I've jumped to there, but right. So I think the most practical thing that we could do now is try and set up a Python virtual environment from this custom-built Python interpreter, and then we can start building PyO3 to use it too. So then we've got the whole compilation stack working on Rust. So I think if we just do this, is this here? No. But we can, okay, so if we do this, we'll be invoking the local Python interpreter. Yep, great. And we should be able to just create a virtual environment. We will have to check that this is working as we expect, but we'll give it a shot. So let's put it here maybe. Haven't really got a good intuition for where's a good place to do it. I'm going to show up here. Oh, okay. We probably are having problems because we okay, that worked. There's probably some more fine details about setting up this virtual environment, which I'd need to check my memory or have a look for. But so what did it say when we tried to run ensure pip? Oh, that's worked this time. I am a bit puzzled as to why we've got that going on. Let's think about this. So we're struggling to set up a virtual environment, which I don't really want to get bogged down in. What we'll try is instead, let's just see if we can get PyO3 to build against this directly. So maybe if we... It's a bit cramped. Hopefully we can do that. So PyO3, we can override which Python we build against by using this PyO3 Python environment variable. So if we... Hopefully if we try this, we're going to run PyO3's main library tests against our locally built Python. Great. Okay. So we're kind of hitting the sorts of errors which I'd expect, which is that we don't have the shared library on the path, but we can do that by adding LD library path. I talk a little bit. There's somewhere in the PyO3 guide where we talk about building and distribution. If you're kind of fiddling around, where is it? Is it in here? Yeah, so we're doing some embedding here because we're running tests against Python's shared library that we've just built. And we have to make sure that the shared library is actually available for us to load. And normally this path isn't in the shared library search path. So we're going to have to just add this to our shared library search path by using this LG library path variable. It's a bit messy. This is probably not the way that you'd want to think about doing this in like a proper development environment, but I think for the sake of getting something to compile so that we can test against our local CPython, I think this should now work. That looks like it's building. Library not found, Python 3.13. Okay. Oh, this is going to get a bit more fiddly because I think if we can debug this. If we use the environment variable, PyO3 has one built in to tell you what it's finding. What we can see is that we've got, it's figured out that we've got Python 3.13, so that's looking good. But it thinks that the library directory where we'll find the shared library is, okay, so we can just run with PyDebug. So we'll go back to with PyDebug next time we build. But the shared library directory, that's probably been built into the Python interpreter that PyO3's discovered that from, because that's where the Python interpreter is expecting to be installed. Let's just shove that into a file here. So PyO3, if you're getting really into the weeds, you can configure PyO3 to build against exactly what you want. And so we just know for now, I'm just going to do this. This is a bit quick and dirty. Oh, hang on, that's not right. That should be okay, because that's where we had our compiled CPython library go into. And so this is just for the sake of, now I need to remember what it's called. PyO3 config file. So we can use PyO3 config file to override what PyO3 is trying to detect and force it to use our locally built CPython. Oh, wants an absolute path. Fine. And we've forgotten to put our LD library path in. Hopefully, once we've done this, so we're overriding PyO3 to use the locally built Python interpreter. We're telling Linux's shared library loader that we want to add that to the library search path. And now we want to try. Okay. We've still got some problems. This is getting a bit tough, isn't it? That is because Python's still configuring itself to look. We really should have considered running, I think it's make install back over here, which would have put this Python interpreter somewhere else. And probably that would have been a practical next step, because it would make more like a real Python interpreter install in some custom location. In fact, I think we might struggle to get any further without that. Oh, maybe we'll be okay. We want this directory. Let's give this one more go. If we can't add one more environment variable to make it work as is, then we should probably go back to the Python build stuff. Yeah, by running make install. Probably we should. I think I need to do some configure steps to get that right as well, David, because if I'm not careful, running make install, because the Python interpreter is expecting to be installed into this user directory, I could accidentally end up writing my system in Python over with this locally built patch. So I would need to reconfigure to tell Python to go in the right place. I think first, I'm just going to try one more. which is, I'm going to try, I think it might be this. No, that's not worked. All right, let's go back and get this to compile properly. So we want configure, and Suf has pointed out we want with PyDebug. So let's do that. And we're going to need to go back to the CPython dev guide, and we want prefix. There we go. And it looks like the recommendation there is to use temp, which seems fine. We've just happened to be at the right spot in the CPython dev guide to spot that. I think what this will do is if we configure it now and then build one more time, then we can run make install afterwards, and we should end up with our new locally built CPython just going into the temp directory, which we can then tell PyO3 to run off. And it will probably be a lot easier than all of the wrangling with environment variables, which we didn't just manage to do, which we tried and really, really failed at. Okay, so that's finished. So now we want to build. And following the build, I think we would then run make install. Maybe we could just check first that we're going to do something sane. So if we run this locally built interpreter, hang on, let's put that a bit higher on the screen. So if we do import sys and check sys.path, yeah, this looks promising, right? It's saying that it's thinking this Python interpreter thinks that it's supposed to be installed into TMP. So that's looking promising. So let's just run make install now. And hopefully we've at least got the protection right, that my system Python should be protected by root. So if we've got this wrong, then hopefully we'll get permission denied and that nothing bad will happen rather than my system interpreter getting flattened. So here we go. Great. Yep, so TMP Python seems to be looking promising. So let's just have a look in there. Great. Oh, hang on. Yeah, so we can run that now. And I guess if we go back to PyO3's side, then this should be a little bit easier now. We should be able to, well, we'll just need to fix this command. So we want to use TMP Python. Might be lib. We'll check that if that doesn't work. We don't need the config file anymore because we should just be able to go back to PyO3 Python and point it at our new Python install in TMP. I think it was this. No. Where did we put it? Oh, it's only got a Python 3. It doesn't have a Python link, sym in there, so that's fine. Now we're compiling. And we ran, but we did have a crash. That's not the end of the world. So we've got success. We've actually managed to build PyO3 against this new Python 3.13 interpreter, and a bunch of the tests did start running. We had a seg fault because this PyO3 wasn't yet configured to run against well, we haven't updated PyO3 to support 3.13 properly because of the kinds of things like the structure definitions that we've just been talking about with Unicode object, and how we're kind of dependent on having some of those mirrored on the Rust side at the moment. And so if some of those have changed between 3.12 and 13, well, we're stuck. one day we'll get that support fixed. We've got, I think the expected release date of Python 3.13 is something like October. So there's some time for us to fix it before then. It would be nice to start being able to enable alpha users of Python 3.13 to use PyO3. So I'd like to do it sooner. Really, I think my timeline is that we'll start by finishing off PyO3 0.21 and the new API that we've got there. And then we'll carry on and look at doing Python 3.13 support, I think, is the next most important thing after that, really. So probably PyO3 0.22. Hopefully we can limit or send some of that. And so other than that, now that we've got this far, so what we can do still is we could write just some tests that we care about, which use this new symbol, and just run those. And because we're looking very specifically at that part of the code base, I should think that those will run fine. So let's jump back over. Let's go into the Rust code again. And so we've just added two symbols. It doesn't really matter where we put them exactly. I guess we could put them after, kind of like mirroring the position. So we put here, on the Rust side, this is going to look like this. It's going to be called Py. How do we call it? We called it with lowercase, didn't we? So let's put this definition in, and it returns the pointer to a C void. And then we also have we called it getKind, didn't we? And again, it takes just a Python object, and it returns an integer. Oh, and we call it C unsigned integer, which I guess is reasonable, though actually I think we didn't specify signedness over on this side. So let's go for C int, which is probably good enough. Great. So those are the definitions that we need on the PyO3 Rust side to be able to use those symbols. And then the final step is let's go look at some of the tests that we originally found at the beginning, which were using Unicode data. So this was one that was using Unicode contact data. It's using a lot of the other versions. Is there any that are just checking Unicode data? Not here. Maybe here. So this is where we currently call kind and data in the PyO3 source code. Do we have tests for this function? Yeah. So this test is creating a new Python string, and then it's accessing the data through PyO3's got a safer wrapper for it. Unsafe because we are reading against this C bit field, and so we can't really guarantee that it's definitely going to work. But we can remove this unsafe once we've gotten a stable representation in the symbols that we've just built. And so we should be able to just change this function. Well, yeah, we should be able to change this function to now use those new symbols that we've just defined. Okay, and it's complaining that they're the wrong type. So let's just cast them like this. Not care about the type for the moment. Okay, cool. So we've changed the data function, which we were looking at down here, to now use our new symbols. And I think that should be enough that if we hop back to the terminal, then this test is, it looks like there's a bunch of them that are all called test string data. So we should be able to just go back to this compile, and then we'll add test string data as a final argument, which will tell the Rust test runner to only match tests that match this pattern. So now we can run this, and these tests all succeeded. which is very reassuring. And I think just to like sanity check that these are really using the code that we thought we built, let's just hop back. So do you remember that when we wrote the implementation, we talked about how we had to check that the type of the input, hang on. Let's go find it. Here we are. We had to check that the input was a PyUnicode object. And if not, we just left it as an assert for the moment because we didn't really think too hard about it. So let's see what happens. What we should find is that let's try and exercise that path when it's not a Unicode object. And we should find that the assertion trips and things blow up, proving really that we are indeed hitting our new code paths. So let's hide the terminal again for the moment and jump back here. So instead of a PyString, let's build a dictionary, which is definitely not a string object. And let's be evil and do what we should never do. Oh, well, let's do it in 2 lines. So first, we're working with the deprecated the dual-refs API here. If you've seen the other streams talking about the new API coming with the bound smart pointer, a lot of the tests still use the old API because that's implemented in terms of the new one. And so we get coverage for both by not changing the tests yet. One day we'll flip these all around. But anyway, so we could lie a bit here and do what we definitely shouldn't do and pretend that this is a string by using downcast unchecked. And so we're just telling PyO3 here that we know that this is a string object. This is never going to work. So there's no point ever trying to do this in your own code. What we're trying to do here is then get this data to call to run through. It should get to this point, calling PyUnicode data from blow up. It might blow up on PyUnicode get length first. And if so, we can rearrange things. Let's rearrange things now. Where were we looking? Here. So inside the data function, it makes these 3 calls. I'm just going to move PyUnicode get length down so that it tries to use our new symbol first. And now if we hop back, we've got compile error. We haven't imported this. Let's just fully qualify it for the moment. We're going to need it on both sides. There we go. Now we've got no compile errors. So if we hop back to the terminal, let's run this test. It's UCS1. And I'm hoping that what happens is we hit that C assertion. Yeah, so indeed, it's here we go. That's exactly what we wanted to see, right? Objects Unicode object.c line 3867 PyUnicode data assertion PyUnicode check failed. And if we go check the source code of what we wrote, line 3867 does indeed line up. So that's great. We've proven that we really are using this interpreter. Why GitHub Copilot turned off? Is it? I forget which one of these many icons it is to check Copilot. Status ready. Maybe sometimes I turn it off just when I'm drafting the occasional piece of like written material, and it's unhelpful to have Copilot writing in that. So I think potentially it was turned off because I was drafting some text last night. I can't remember. But anyway, okay, fine. Copilot should be on again now. But yeah, so jumping back to this, we've proven that doing what we tried to do with the converting a dictionary to a string has just caused everything to blow up, which is Fine. It's probably unhelpful though for real code which got the type wrong somewhere to blow up. So we might want to change this code to do error handling properly. I'm trying to think what else we'd want to do. As far as the PyO3 side goes, we've shown how we can get this to work and that it does. So I think we don't need to do more on the Rust side right now. I think it's just about tidying up on the C side, and then we can look at getting this PR pushed. So let's close the PyO3, or go back to this one for now. Right, so how would the error handling work? I think that the way we would expect this to work in C is we can't return results, but there are normally conventions when writing these functions. So like a pointer, we're expecting to get a non-null pointer back here always, right? And so we get null as the opportunity to return on an error. And I think, are there any other ones? Yeah, so like as UTF-8 and size has this pattern at the beginning, right? Where if it's not a Unicode check, we do this. Yeah, raise system error, return null. And I think probably PyAir bad argument. Oh, it's actually a type error, but that's probably good enough. So let's just copy that block and go down. So by Unicode data back to here. So instead of our assert, let's change this to be PyUnicode check. Oh, we want op here. I guess it might be nicer to call it Unicode. And p size, I think that was related to the length on the other function, so we don't need that. We can delete that away. And I guess we can have a similar thinking for get kind. Let's see how PyUnicode get length works and handles errors. Yeah, so it's returning -1 if the length, if it's not a Unicode. So then -1 is signaling that it's an error instead. So we can do that here. Might as well go for Unicode because that seems to be a convention followed in quite a few of the other functions here. Great. So now our implementation, instead of just asserting and dying, is going to properly check the types, which I think for this API is completely reasonable. We'll have to compile again. And we will have to install again too now, right? Because we've put it into that temporary location. So let's run both of those, and then maybe we'll do one more run of PyO3 against this rewritten version, which should be able to then, we'll see the difference from replacing the assertion with error handling. Cool, I think that's done. That was much faster, so thank you, Suf, for going and finding how to get the quicker compiles sorted. Right, so here we are. And I think if we do this one more time, what am I thinking might happen? So if we go back to our implementation of .data, we want the new API's implementation now. It's not actually checking for errors because these functions that we were using before didn't check for errors. So we'll kind of be in an invalid error state here. It's probably going to be that this will be null here, raw data, because we'll have an error. And I think PyUnicode getKind will probably then call through fine because we're not trying to check for null. We could add an assertion, but I'm just sort of doing a bit of an experiment here to see what blows up. I think we'll go back into PyUnicode getKind, our new function, and I think it will be here that we might have a problem because there will already be an error set. But I'm not 100% sure, actually. So let's just go. Oh no, we've still hit the previous assertion. That's interesting. Which makes me think that maybe the install didn't work properly. That's from 11:30. That is from right now. So maybe PyO3 has not. Oh, hang on. What should we do? Let's just force a recompile. I'm surprised that that's still flipping with an assertion on the same line. Relink PyO3. Yeah. Let's just cargo clean the lot and try again. Wow, it's been a lot of development since I last did a clean. Hopefully we can compare a clean Rust compile to a clean Python compile here, or a clean CPython compile. We want that one, don't we? So there's a few dependencies which we haven't had to compile before, but it shouldn't be too bad. We try not to have too many dependencies on the PyO3 side. Okay, yeah, this is looking more like what I expected to see. So the test has failed. It failed by panicking with an assertion later on down the line, actually. 495. Oh, in our Rust code. So it looks like somewhere else. Where's that? In get length. Okay, fine, because we're currently running Rust tests. And so this debug assert tripped slightly later on. So actually, the real answer there then is that because we didn't check for errors at all in our implementation here, then we've actually ended up just like running through all this code, and it wasn't until here that it blew up. But what we should do is we should have something like we currently, oh, this is a result. So we can just do this to load the error back out from the interpreter. And then we can do the same thing, kind. We set it to be -1, but we've already cast it to an unsigned integer because of these constants being unsigned. So we could just do some error handling like this for the moment. This is a bit crude. There might be a tidier way to do it, but it should illustrate the point that if we now recompile one more time, yeah, this time we're getting the crash down in the test where we were unwrapping here, assuming that there was no error. And instead we have got an error. We've got this type error, bad argument type for built-in operation, which was what I think the PyAir bad argument that we did over in the C is going to be creating. So that's all kind of wiring up as we expect. Okay, so I think we can put away PyO3 for the moment again and just go back to finishing off this CPython patch. I'm not sure that there's anything much else that I would think we want to add to this. Actually, there are already these. So cool. Okay, it's good to see that we actually do have Unicode get length already. And then we've got to match kind of what we're doing with get kind. So I think that we can probably commit this and push this up. So if now that not a built-in operation. Can you elaborate a little bit more on what you mean? I'll start preparing the commit while we figure out that. Cool. So we've made these two changes. So preparing a PR to CPython. Let's go look at the CPython GitHub. Oh, any of these will do. Oh, that's not very helpful. Here we are. usually what happens is when a pull request is opened, not built-in operation. Oh, I see. You want the error message to be... Yeah, the error message could be better. I think on the... Well, the point is that we're kind of... That error message that we just saw here, we shouldn't really ever hit this on the PyO3 side, because the reason that we did is only because we were pretty evil and... Oh, I see, Sue. You're talking about the C function. We should put a better name for it. I think, though, let's go compare it to get length. I think the point is that we're doing the same as what the other operate LC APIs for Unicode were already doing. And on the PyO3 side, we shouldn't ever hit that error because we shouldn't be, we deliberately forced it with some unsafe code, but we should always have a string. And so we never really expect these to ever error as far as PyO3 is going. So these can probably, we might as well just do the error checking anyway, but we shouldn't ever expect to hit this line because it should always be a string object as far as the nicely typed Rust side goes. But it's worth checking. So if we go look, Unicode get length, yeah, so that does exist. And so I think if we compare to PyUnicode get length, then yeah, it was just using PyAir bad argument again. So I think that there's good justification that we've followed an existing convention on how these APIs are working. Like really, it's the caller's responsibility to always be passing a Unicode object in. And so these are just sanity checks because really bad stuff happens if it's not the case. So I think you don't really ever expect to see this error message come up in Python code, this bad argument one. It's kind of a C programmer or Rust programmer error if you hit them. So let's just proceed back to CPython on the GitHub side. And so what tends to happen with the CPython PRs, as far as I understand it, is that they like to have an issue which has discussed the problem first, and then a follow-up PR, which is fixing it. And so these issue numbers we're seeing here are the issues that we're trying to fix. And I think if we jump back to what I had in PyO3, I linked this one where I was talking about this particular problem a year ago. Oh, is that a bit small? Maybe one larger? We'll see with that for the moment. And so we have an issue. Let's go see whether this is... oh, okay, this is quite a big blanket issue, really. Reliance on C bit fields and C API as undefined behavior. And there's lots of reasons why that's not desirable. And actually, this wasn't opened by me, was it? This was opened by, I think this was a bot. Oh, yeah. So Indie Greg, who does PyOxidizer and a few other really, really useful projects, wrote this. It's talking about how we'd prefer not to have it. And in particular, it's talking about... So I think it's probably okay for us to put the pull request against this issue number for the moment. If the CPython devs want us to change that later, then so be it. I can take responsibility for carrying this request again through review. Hopefully, we get this into Python 3.13. We've got... I can't remember when the beta freeze is for Python 3.13, but I think it's still a couple months off. So there should be time to, either get this thing through to completion or be told that it's not on the cards. And we'll see which way it goes. So hang on, that's PyO3. Let's make this... Well, what was that issue number that we were just looking at? It was 89188. So let's add We'll push that and see what people think. So I'll push that to my fork. It looks like my fork was a long way behind upstream CPython, so I'm having to upload a whole load of development that's happened since I last pushed a patch. And in the meanwhile, we can go back over here and get ready to create that patch. Great. Cool. I tend to just do it using GitHub's button. Okay. So then there's CPython's got is the browser window a bit small? Should I try and fiddle around with OBS to put this in the center now for everybody? I have no guarantees that I'll do a good job of, of moving it, but I can give it a shot. Would that be helpful, or can you read what we've got over in this browser window on the left at the moment? I'll keep going, but if I see comments in chat saying please move it, I can give it a shot. So what have we got? It's first asking us to get the pull request title in the right format, so we've done that. Looks okay, a bit small. Okay, sure thing. I guess the problem is that making it that big, it is going to be hard to then see. So I think let's have a little battle with OBS here. Unicode get data. Yeah, that is a good point, Bruno. It probably is better to call it PyUnicode get data. Yeah, maybe. I think what I'll do is carry on with getting this patch uploaded, and then let's put a comment saying it came up as an alternative was PyUnicode get data, and then see what the core devs say. I think you're probably right. It probably is more consistent to go for that. So I think we will. All right. Let's see if I can get this to work. What I can try for the moment is we can move that. How is that? That's actually not too bad, is it? It's a bit nicer. I'm just going to play around and see. Now that I'm messing around with OBS, the trick to get your PR accepted is to leave an obvious nit. That's not a bad shout. Then people will bike shed that and decide that the rest of it is fine and we'll get through. So let's do that. I'm just going to check for my own sake of understanding OBS. Cool. All right, so that's not too bad. I can just flip it back and forth like that. Great. Okay, let's put this in the center for now then. And make it bigger. Hopefully that's big enough. If any other changes need to go, then we can do those, but I think that should be all right. Cool. Getting better at this streaming thing. We're on week 4 now, I think, and I think slowly I'm figuring out how to get OBS to put things in the right place. Thanks, Danger Crow. I think you've joined previous weeks as well, so good to see you again. Thanks for joining. Right, great. Yeah, I think the font size will be all right. I tried it on a mobile device to look at this before, and it was a bit tiny, but I wouldn't expect that there's too many people wanting to look at this on mobile. But if you are viewing on mobile, it'd be really helpful to know because we can try and accommodate everybody. Okay, cool. So what we're doing, we were looking at the format. It wants us to have the format of the PR title, which I already spoke about. I've done that correctly because I'm a bit used to that. This isn't a backport, so we don't need to worry about that. There's not actually anything else that the template's talking about. So let's clear that. And let's say and it's inspired by the comment that Peter gave me. Oh no, it's not in this PR, sorry, it's down here. I tried this before by taking the state away and just turning it into separate fields, but there were good reasons not to do that. So this PR we can close. now that we're going for a separate solution. So we'll just go put this here. Add. So the idea is to add PyUnicode data and PyUnicode get data to the version specific API as exported symbols, that we can use these downstream in PyO3 instead of having a dependency on the C bit field. PyUnicode get. Oh, thank you. I'm jumping ahead to Bruno's suggestion. Bruno, if you're happy to have your credit put against the name suggestion, then I can do that. If you don't want me to directly link you, I can take this out. And then maybe as a final comment, Peter didn't want these added to the stable ABI due to concerns about exposing encoding and also dangling pointers, which the dangling pointers is fortunately less of a problem from Rust because we can have left references to tie the lifetimes back to the original Unicode object. Okay, I think it sounds like we're likely to get PyUnicode get data as a refactor that I'll push later. Cool. And then let's just sanity check. So we've got that. Oh, this is a bit messy. We probably should tidy that up, but I think we'll wait for a review to at least confirm whether this sort of is going in the right direction before we do it. Probably we're going to be asked to add tests as well, which we haven't covered. So I would bet that that's the first feedback that we'll get. I'll just add a mark for that at the moment. And then, yeah, if it looks like this is moving forward, I guess we might end up doing the symbol rename. We might end up adding some tests and actually documentation too, right? But I guess the goal here was to show how we can do this kind of patch, test it against a local PyO3 today, and then just go through the ceremony, I guess, of getting onto the PR as well. Because I think there's one more step, because if we do this to create the pull request, that's now up there. So if anyone wants to go ping or review or thumbs up it, then it's issue or pull request 115211 on GitHub. I tried to send something to Stream Chat before as a URL, and it looked like it got filtered. That seems like it's gone through today. So there you go. I've given the link in chat. If you want to go through, we probably don't want to swarm the core devs with comments, but I'm sure a thumbs up would be welcome. And the final step, which I was just going to talk about, is that it's important to add a changelog entry. And I've always done this through a little helper bot to get this done. I can't remember where it's called. The CPython dev guide knows this, so let's jump back to that. Oh, I've lost the CPython dev guide. I should really bookmark this thing. What we're looking for is pull requests. Pull requests. This is probably it. News. Great. No, that's not it. How to add a news entry. This is what I was looking for. So they go into the subdirectory of the CPython repository, and there's an online tool to do it, which I've shamelessly used every time. So if we just sign in to this, then we can put in the details we need. So we want 89188 in here, which is the issue that we're originally claiming against. The pull request we just opened. I think I've got that still on the, there we go. And choose an option. I guess this is CAPI. Let's just go for add PyUnicode get data. I'm doing it now, aren't I? PyUnicode data and PyUnicode. It sounds like Bruno's definitely right on using get data. Okay, I guess to PyUnicode and PyUnicode. Oh, thank you. Sorry about that, everybody. So this tool is it's when we click this, it's just going to add a commit on top to put the news in the right place. I think in principle we could have just done this ourselves as part of the commit, but I don't remember the full details. I think it uses restructured text, so we need to use double backticks. So that's probably good. This is where this will end up is if we go to like what's new in Python 3.13, for example, then these are all the highlights, which I think are manually curated. I can't remember the full detail. And then there's somewhere a full change log here. And so these bullet points are populated from all these fragments of snippets which we add in this tool. So if we go ahead and do that, then we should see this go through. Great, yeah. And this is exactly why I didn't try to create this file myself, because it's got conventions about the name and what it's supposed to be called, I think. And so it always scares me off, and I prefer use the tool to just get that right. And we can see that the bot's added that second commit. Cool. So we've added the changelog entry to this thing too now. And I think that's a pretty good place to wrap up the stream today. So I guess hopefully we'll see what the feedback from the core developers is on this one. And then if you've got any other questions before I close off the stream, now's a good point to put them in chat. Otherwise, you can drop them as comments or reach out to me directly on I've got LinkedIn, Twitter, and Mastodon tend to be the 3 social networks which I use at the moment. Or indeed just on the PyO3 GitHub discussions are also a very good place to put things. Next week, I think we'll probably do the other idea that I had that we didn't look into this week, which was about the procedural macros. So the idea would be, let's just jump over back to VS Code very briefly. And we can move the browser back. So I think if I just resize it like this, then over on OBS it's going to jump to. That's better. We're learning this streaming thing here. It's good. Cool. Thanks very much for joining, David. Thanks, Suf. I've enjoyed giving this stream today. It's been cool to have everyone giving ideas and helping shape out what things have been going through. So yeah, just to talk about next week. Um, yeah, I totally understand that, Bruno. It's one of those tricky things where I couldn't quite figure out whether to go for streaming live on evenings or weekends or what kind of time of the week. For the moment, I mean, I've got a young family. I've got a toddler who's coming up to 2 in a month, and so Friday mornings seem to be the time that fitted the family best. And so for the foreseeable future, at least, I expect it will be this 10 a.m. to 12 p.m. UTC slot. But obviously, I will always make sure the videos are available on YouTube afterwards. And I try to go back. I haven't done it for last week's yet, actually, and add chapters just to describe how like the different segments of the stream fit together. Yeah. Yeah, weekends are definitely difficult. I wondered whether evenings might be or suitable for some. One advantage about doing evenings UTC at least is also that the Americans can join, because I mean this time in the morning is good for us, but it's really, really awkward for, I guess, American viewers. So like one option was maybe UTC afternoons as well when it's morning Americas. But at least for now, it seems like mornings fit best for me. And like ultimately, if I can't do it, then there's no stream. So we'll probably stick to the morning slot for now. But hopefully, if there are slots that make sense for other people, like let's try. I'm always happy to take feedback. And even if I don't regularly fill a particular slot, maybe I can do one-offs in like different slots that are good for different people. Anyway, yeah. So just to round off, I think what we'll look at next week, if we just look at an example quite quickly. What's a good one to look at? Afternoon would suit you better, Bruno. Okay, that's cool to know. So afternoon slot, it probably won't change in the near future, but maybe it's something that I would quite like to be able to let the Americans fit. So if we can find a way to do that in the future, it might be nice. I'm just trying to think of a good file to look at. Oh, this one. So here's a good example of what I think we'll try next week. These are Python functions that we've written in Rust using the PyFunction macro that are taking these deprecated GIL-refs or GIL-refs. I'm never quite sure on what the pronunciation is supposed to be. And at the moment, as the way this goes, we'll release PyO3 0.21 and we'll tell you that we want you to get off these things. But if you use them in functions like this, we won't be marking them as deprecated. And I don't really want to I can't deprecate the types. It's a G as in GIF. Okay, so GIL then. Okay, that makes sense. Thanks, DangerCrow. I will do my best to internalize that after years and years of reading it wrong. So I can't deprecate the types because we still want to be using the types, right? Like the replacement that we want people to get to here is this. But it would still be very nice to have... Oh, it was a joke. Okay, so you're not sure either, Danger Crow. Okay, cool. Well, if anyone knows, maybe there is no right way, but either way, maybe it's going to be removed, right, in Python 3.13 and in the future. So maybe I can just be wrong for a few years and then the problem goes away. But yeah, so we can't deprecate the type, but it would be really nice to have users get a deprecation warning that they're doing something we don't want them to do anymore here. And so to do that, I think we're going to have to dive into the procedural macro here and see if we can get it to conditionally emit a deprecation warning, probably through some evil stuff with traits, to get it to emit this deprecation warning if they're using types that we don't want them to use anymore. It would be a very nice thing to have. If we can't figure it out, it's not the end of the world, but I have an idea that might work and it would be cool to dive into it and see what happens. Anyway, so that's what we'll cover next week. Thank you again, everybody, for joining today. It's been a lot of fun. And I'll catch you next week, hopefully. Yeah, and sorry that we won't see you next week, Bruno, but hopefully you can keep in touch over the catch-ups. And obviously, I communicate with you regularly on the PyO3 GitHub anyway. But cool. All right, all the best, everybody. I'll kill the stream here.